Amanda Fetch, aka Dr. Amanda Analytics, and on my channel I break down how space-based systems and technology provide us with situational awareness of dynamic environments, whether that's an Earth or in orbit. Santa is a symbol of a global overnight journey and a great moment to show how space situational awareness actually works. So what I'm going to do today is walk through a short real data analysis using space-based satellite imagery. And what I'm going to focus on isn't necessarily modeling routes or optimization, but I'm going to focus on how analysts would use space systems to understand what we can see, what we can't, and why at a specific moment in time. And so this is like thinking and almost a model of a space situational awareness, and an idea of a global overnight journey is very familiar through traditions like the Santa tracker, which is run by NORAD. Now that's a pop culture way of imagining global awareness. So what I want to show is what that same night actually looks like from space using real satellite data. So for this analysis, I'm using full disk day-night cloud microphysics imagery from the GOES East satellite operated by NOAA. And so this is basically a space-based sensor. Well, I should say these sensors are space-based sensors in geostationary orbit that continuously monitor half the planet at once, even at night. And so I went to NOAA's GOES image viewer, selected GOES East, chose the full disk view, and used the day-night cloud micro combo RGB product. And so what that product does is lets us clearly see cloud cover and atmospheric constraints on the night side of Earth. And it does this in a single snapshot. And so the question I'm looking to answer is, on this moment this evening, what limits global awareness of Earth during the nighttime? So first, Earth is divided into a day side and a night side. Earth's total surface area is about 510 million square kilometers, or for the purpose of this analysis, yes, let's use that number, which means roughly 255 million square kilometers are in darkness at any given moment. And so that night hemisphere defines the maximum region where nighttime situational awareness applies. And so after this, we examine and we look at only the night side of the image and identify dense cloud systems. And so in this specific image, brighter regions correspond to thicker, higher cloud tops, which act as environmental constraints on visibility. So if we look at this snapshot, approximately 45 to maybe about 50% of the night hemisphere is affected by a significant cloud cover. And so when we do the math, that's corresponding to roughly 115 to 128 million square kilometers of the planet experiencing reduced visibility at this moment in time. And so what this analysis is looking at is we're bounding the environment. And so again, I'm not necessarily optimizing or predicting anything. And so this is more of a classic situational awareness problem. And so in space operations, we deal with the same sort of challenges: environmental interference, limited coverage, time-dependent geometry. And so the key insights that I'm looking for here is that global awareness is constrained more by timing and environmental conditions than necessarily by scale alone. And so as the Earth is rotating, these constraints move continuously. And so tonight in Santa is a pop culture moment, I should say in Santa's journey, is a pop culture moment that makes this intuitive. And so we experience the night locally, but space-based systems observe it globally. And that contrast is exactly what situational awareness is about. Now, before I wrap up, I want to leave you with a discussion question. Now, in situational awareness, in space situational awareness specifically, what do you think is the hardest challenge? Coverage, environmental interference, or timing? And why? Let me know your thoughts in the comments. Happy holidays, and I'll see you next time. Take care.